Now, let's extend our skills for reading data frames from files. We'll use a comma-separated values file of sunspot observations collected from SILSO, the Sunspot Index and Long-Term Solar Observations. The entries date back to the 19th century with over 70,000 rows. The readCSV function requires a string describing a file path as input. We read into a data frame called sunspots. Using the info method, we see the data frame has mostly integer or floating point entries. Notice the index of the data frame, the row labels, are of type range index, that is just integers. Let's use the accessor.ilog to view a slice of the middle of the data frame. We can now see some of the problems. The column headers don't make sense, and there are some perplexing -1 entries in one column. What's going on? First, the CSV file does not provide column labels in a header row. The column meanings can be gleaned from SILSO's website. Columns 0 through 2 give the Gregorian date. Column 3 is a decimal value of the date. Column 4 is the number of sunspots observed on that day. And column 5 indicates confidence in the measurement, 0 or 1. Second, the -1s in column 4 denote missing values. We'll need to take care of those. Finally, as written, the dates are awkward for computation, a common problem with CSV files. Let's tidy this up. Using header equals none prevents pandas from assuming the first line of the file gives column labels. Alternatively, an integer header argument gives the row number, indexed from 0, where column labels actually begin and the data begins. Notice now the columns and rows are assigned integers from 0 as labels. We can explicitly label the columns with the option names. We define a list of strings col names to label the columns properly. We can also read the -1 entries in the sunspots column as NaN, or not a number, sometimes called a null value. We do this with the NA values keyword. We try NA values equals quote -1 quote, but the sunspot column still has entries of -1. Looking at the original CSV file reveals the problem. There are space characters preceding -1s throughout column 4. Thus, we use NA values equals quote space -1 quote, and it works. Notice the sunspot numbers are now floating point values and not integers. Several strings can represent invalid or missing values. To do so, we use a list of strings with NA values or a dictionary mapping column names to lists of strings. Note it is possible to use distinct patterns for null values in different columns using dictionaries. See the documentation for examples. Finally, we remember the year, month, and date columns can be loaded in a better way. The past dates keyword in readCSV infers dates intelligently. We use a list of lists of column positions indexed from 0 to inform readCSV which columns hold the dates. Sure enough, there's a new column of date times named year, month, day, amalgamating the 3 original columns. In fact, using the info method, we see year, month, day column has entries of type date time 64. We'll learn more about date times when studying time series. They're invaluable for many time-based computations. Also, the sunspots column has about 69,000 non-null entries. The data frame still lacks meaningful row labels as index. The year, month, day column can be assigned as a data frame index using the index attribute. Similarly, assigning date to the index's name attribute gives a more concise label. Notice we still have the year, month, day, and dec date columns. To get rid of them, we list the meaningful column names and extract them. The result is a more compact data frame with only the meaningful data. What if we want to share this new data frame with others? The sensible thing to do would be to export our compact data frame into a new CSV file. The method toCSV does the job for us. Like readCSV, the toCSV method has a host of options to fine-tune its behavior. We can even export to Excel using the toExcel method. Try some exercises now to practice loading and saving data frames.